In this video, we're going to take a look at a velocity graph and making conclusions based on the graph of just the velocity. So first off, let's make sure we're all very aware that this is velocity. And in all of these questions, we just have to answer according to what has happened at these very specific points of T1, T2, T3, T4, T5, T6, and T7. So all our answers are with just looking at those particular points. All right, so the first question asks us, when is this particle moving to the right? It's going to move to the right when velocity is positive. That's going to happen at T1, T2, T6, and T7 because those are the 4 points that are above the x-axis. The next question asks when velocity is decreasing. Well, we're looking at the graph of velocity, so it is decreasing when it has a negative slope. So at T1 we have a positive slope, at T2 we have a negative slope. At T3 we have a negative slope, but at T4 it is a positive slope. T5 has a negative slope. T6 has a positive slope. T7 has a negative slope. Next, we're asked, when is the velocity the greatest? Well, velocity is the greatest for whichever one has the highest y value. So if we look at these positive ones, T1, T2, T6 is higher, T7 is lower again. So T6 has the highest velocity of the ones marked. Next, we're asked for the ones with the least velocity. So we're going to look at everything below, and we quickly see that T3 is the lowest. Now next we're asked about speed. When is the speed the greatest? Now recall that speed is the absolute value of velocity. So now we don't care about whether it's negative or positive, and we can see that T3 is much farther from 0 than T6. So our particle is zipping along much faster T3 just in the left direction. So that's when it's the greatest. And our speed is going to be the least, the one that's closest to 0. And so we can see that T2 is the closest to 0 of the 7 points. And so that is going to be when speed is the least. All right, continuing on, our next question asks about when is velocity positive. Well, it's important to note that, when is acceleration positive? Acceleration is the derivative of velocity. So it is positive anytime my velocity has a positive slope, which is very similar to this question, which was asking when was velocity decreasing, and we were looking for all the negative slopes. Now we're going to be looking for positive slopes. So we're looking for when is V have a positive slope, So our answers are going to be at T1, T4, and T6. T1, T4, and T6, because our velocity has a positive slope, which means our acceleration is positive. All right, next we are asking, when is acceleration increasing? That's like asking, when is V prime increasing? Well, we know V prime is increasing when V double prime is positive. And we know if V double prime is positive, that means that V is concave up. So if we look at this graph here and figure out when it is concave up, we'll have our answers. So this first part is concave down, but I can see that I'm definitely going to be concave up along this region here. And again, in this region here, I'm concave up. And so my answers to this one is going to be at T3, T4, and T5. All right, let's look at the next one, which asks me, when is acceleration the greatest? Well, acceleration is going to be the greatest when V prime is the greatest. And that means we're looking at the slope of V. And our slope of V is going to be the greatest when it's the steepest of these. So if I look at my positive slopes, there's one, there's the second one, and there's the third one. I can see that the steepest one, this one's really more like this, is at T4. So I'm basically looking at those 3 slopes and seeing which one is the steepest, and I can see that that is the steepest one there. All right, so for when I'm looking for when is acceleration the least, I want to know when the slope of velocity is the least. And so I'm again looking at the slope of v, but since it's the least, I'm going to look at the negative slopes. So I really want the steepest negative slope in this one. So if I look at these ones, and I can see that right here at T5, this is the steepest of the negative slopes. All right, lastly, I'm asking about when is the particle speeding up. Now, to be speeding up, our velocity should be going away from zero. So notice what's happening here. My particle starts at zero, and it's it's speeding up because it's going faster in the right direction. So I'm going to just trace this with two colors. So if it's going faster, I'm going to use green. So I start at zero and I'm heading up here. I'm going faster. But when I come back down towards zero, I'm going slower. I go from zero and I'm going faster. Remember, T3 was a really fast spot. And I'm going really fast here when I decide I'm going to brake and head my velocity back to zero. And then I decide to go faster again. And then I decide to, my velocity goes to zero. And then, oops, I'm speeding up again, and then right here, I'm slowing down. So do you see how every time I'm moving away from zero, I'm speeding up? When I'm moving towards a velocity of zero, I am slowing down. Speeding up, slowing down, speeding up, slowing down, speeding up, and slowing down. So when is it speeding up? All those green times. So let's write those down and let's talk about them just a bit more. So at T1, I am speeding up. And let's think about what we learned before, that our slope and our velocity and our acceleration have to have the same sign. So let's take a look here. Our velocity is positive, right? And our acceleration is positive because we have a positive slope. Our next one that fits in here is T3. And if we look at T3, notice my velocity is negative because it's below the x-axis, and my slope is also negative, same sign. Same thing with T5. My velocity is negative and my slope is negative. And our last one at T6, my um, my velocity is positive and my slope is also positive. So it works with our old definition of saying velocity and acceleration have the same sign. It also works by looking at the graph to saying, when am I moving away from a zero? So a velocity moving away from zero is speeding up. If you're moving towards zero, you're slowing down.